Right, welcome to mathematics. I'm Sir Mangeya. Well, last time, first part, I worked out it's a Cambridge advanced level. It's an A level question paper, pure maths. It's paper 1 for 2017, right? So I worked out from question number 1 up to question number 4. So now on this video, I'll be working out from question number 5, right? So bear with me. And after watching, please remember to subscribe, remember to share, remember just to share with others, right? Just be able to share with others. That one is actually nice. Make others also know this good stuff, because these are actually the best videos. I'm sure you can that one you can agree with me. Subscribe, and subscribe. Right, so let's get started. On question number 5. We're on question number 5. So this one is question number 5. It's saying a curve-based equation y is equals to 8 over x plus 2x. Find dy dx, which is the gradient, and d squared y over dx squared. Right, so for you to be able to work this one out, right, on this one, make sure that the x there is supposed to be on top, right? Because you can put x if it's up there, then you can't be able to work it out. So let this x be a numerator, not a denominator, like what it is like this, right? Then what we're supposed to do is, let's write it down. We say y is equals to 8x to the power minus 1, applying the laws of indices. Any number raised to a negative power, the same is 1 over the same number when raised to a positive power. So we just give the power negative. The power of x is 1. Give it negative. Then now you differentiate. So dy dx is equals to 8 times minus 1 x to the power minus 1 minus 1, then plus differentiating 2x. What do you get? You get 2. Now this one will be equal to minus 8x to the power minus 2 plus 2. This one can be simplified to minus 8 over x squared plus 2. So this one is the simplified version. Now the second one, the second derivative, d squared y over dx squared. D squared y over dx squared. It's better to use this one. Yeah, you just see better use this one. Alright, so it's equals to, it will be minus 8 times, we're differentiating that one, minus 2x to the power minus 3. If you differentiate a constant, what do you get? Differentiating 2, you get is 0. So you just leave it like that. So it will be here, minus 8 times minus 2, it will be 16x to the power minus 3. Simplifying this one, you get 16 over x cubed. So this one will be d squared y over dx squared. D squared y over dx squared. That's the second derivative. Right, let's move on to the next question. Next question is saying, find the coordinates of the stationary points and state with the reason the nature of each stationary point. Right, to find the coordinates of the stationary point or the turning points, what do you do is what? You just find gradient and equate to 0. Because at turning points, gradient is always equal to 0, which is dy dx. So dy dx is always equal to 0. So where is our dy dx? We just equate that one to 0. Right, it's here. You can take it from this one. You can take this one. Minus 8 over x squared plus 2. Then equate that one to 0. Minus 8 over x squared plus 2. So you say minus 8 over x squared plus 2 is equal to 0. Then if you simplify this one, you solve this one. Right. Get rid of the denominator first, which is x squared. How? You multiply everything by the denominator, which is x squared, right? If you can multiply here, it will become minus 8 plus multiplying there, it will become 2x squared. then is equals to 0 times x squared, it will remain 0. Then here you simplify, 2x squared is equals to 0 plus 8, it will be 8. Then after that, divide by 2. You can divide by 2 here, you get x squared is equals to 4. Right, then now, what you want is x. So x will be equal to square root of 4. Square root of a number, remember, is plus or minus, right? Because if you want to get rid or to remove the square, you use square root. Remember, with x squared is equals to 4. You want to get rid of this square, you use the square root. You put square root both sides. So x is equals to plus or minus 2. That's the final answer. X is equals to minus 2 or plus 2 or 2. Now, we want to find the corresponding y coordinates of these turning points. How can we find them? Use the original equations. That's the one that you are supposed to be using. The original equations. Where are the original equations? This was the original equation here. The one that you are supposed to, you are going to use, right? So let's use that one to find the corresponding y values of x, right? Here our equation is what? Y is equals to 8 over x plus 2x. Y is equals to 8 over x plus 2x. Y is equals to 8 over x plus 2x. So this one is our equation, right? So the corresponding y values, first part, when x is equals to minus 2, what will be y? Y is equals to 8 over minus 2 plus 2 times minus 2. If you can simplify this one, what do we get? So it will be 8 divided by minus 2 is minus 4. Then 2 times minus 2 is minus 4. Minus 4 plus minus 4 is minus 8. So this point now is minus 2, minus 8. So we found one of the points of intersection, right? So that's one of the points of intersection. Then now let's find the other point of intersection. When x is equals to 2, what will be y? Y is equals to 8 over 2 plus 2 bracket 2. So where there is x, you just substitute, we put 2. Simple. Then 8 over 2, 8 divided by 2 is 4. Then 2 times 2 is 4. 4 plus 4, it will be 8. So the other point of intersection, it will be, we start with the x value. So it will be 2, then 8, like this. So this one is the other x coordinate of the point of of the turning points, of the stationary points, turning points. So we have 2 turning points in this case, right? Then the nature of these turning points, let me put my line here so that I can calculate the nature or determine the nature of these turning points. Right, the first part, when x is equals to minus 2, what will be d squared y over dx squared? Because the nature is determined by d squared y over dx squared. So if dxy over dx squared is greater than 0, then we can deduce. If it's greater than 0, then you can deduce that that point is a minimum point. Minimum point. Then if d squared y over dx squared is less than 0, then you can conclude that that point is a maximum point. It's a maximum point. Right, now let's now use our x values to deduce the minimum and the maximum point. Or are they both maximum or minimum? We never know. So let's just substitute the values of x in d squared y over dx squared. Right, we've worked out d squared y over dx squared here. Up here, it's 16 over x cubed. 16 over x cubed. So we just substitute there. So we say when x is equals to minus 2, d squared y over dx squared is equals to 16 over minus 2 cubed. 16 over minus 2 cubed. Simplifying this one, you get minus 2, which means d squared y over dx squared is less than 0. So which means this point minus 2 8 minus 2 minus 8 is actually a maximum point. Alright, let's move up, let's move down, and let's calculate given that x is equals to 2. So when x is equals to 2, d squared y over dx squared is equals to 16 over 2 cubed, which is equals to 2 cubed is 8. 16 divided by 8 is actually 2. So you can see that d squared y over dx squared is greater than 0, which we can conclude that this point 2, 8 is actually a minimum point. Right, so we are done with this part. Let's move on to the next part. Question number 6 is saying a curve is equation x squared minus x plus 3, and a line is equation y is equal to 3x plus a, where a is a constant. Show that the x coordinate of the points of intersection of the line and the curve are given by the equation. That one, you can see that one right on the screen. So if this the line and the curve are intersecting, then it means this value y, these values are equal to this one. So y is equal to y. Just equate the equations of the two, the curve and the tangent, and the curve and this one, this line, right? So let's equate. So just say this one is equal to this one. So it will be x squared minus x plus 3 is equals to 3x plus a. You can simplify this one, collect like terms. Make sure the right side is left with a 0. So collect everything to the right side, to the left side. 3x then plus 3 minus a is equals to 0. Right, minus x minus 3x is minus 4x. So it will become x squared minus 4x plus 3 minus a is equals to 0. Right, so now we've shown, but let you just put in brackets is what is there, and so that it will just be exactly the same. So it will be x squared minus 4x plus 3 minus a is equals to 0. So you can conclude that we have proved that. Then item number 2 is saying, for the case where the line intersects the curve at 2 points, it is given that the x coordinate of one of the points of intersection is minus 1. Find the x coordinate of the other point of intersection. What you're supposed to do is simple. Use this equation that you have just found up there. Right, you start first, you substitute x minus 1. Then you find the value of a. Then after that, you make that equation as a quadratic equation to find the other x values. Right, so let's do it. Substitute where there is x, let you put minus 1. So it will be minus 1 squared in that equation, minus 4 times minus 1 plus 3 minus a is equal to 0. If you can simplify, you get 1 here, then plus 4 plus 3 minus a is equal to 0. Then this will give you 8 is equals to 8. So a is equals to 8. Now we substitute in the same equation. Right, so you substitute in the same equation with this above here. You get x, so you replace a with 8. X squared minus 4x plus 3 minus 8 is equals to 0. Then let's work this one out. Let's work this one out. You get x squared minus 4x minus 5 is equals to 0. So that will be the your quadratic equation, right? So that's your quadratic equation. Right, now let's simplify this quadratic equation. How can we simplify this quadratic equation? How to simplify this quadratic equation? It's actually simple. What I'm supposed to be doing is you do it like this. You do it like this. So you take this value and this value, you multiply them together. X squared times minus 5 is equals to minus 5x squared. After that, you find two values. These are factors of minus 5. These numbers, when you multiply them, they must give you minus 5. When you add or subtract them, they must give you the middle value, in this case, which is this one, minus 4x. Which are the numbers? By try and error method, the numbers are actually, it's minus 5x and x. Minus 5x and x. So you replace the middle value with the factors. So you say x squared minus 5x plus x, then minus 5 is equal to 0. Yes, so it will be, you factor out x, it will be x minus 5. You factor out 1, then it will be x minus 5 is equal to 0. Then it will be x minus 5 in brackets x plus 1 is equal to 0. It's either x minus 5 is equal to 0 or x plus 1 is equal to 0. So it's either x is equal to 5 or x is equal to minus 1. So based on this, what is actually needed, because we are given one is the one of the x coordinates minus 1, so the other one is obviously it's 5. Then you are done. So that's how you work this one out, right? That's how you work it out. Right, then next, let's move down. As for the case where the line is a tangent to the curve at a point P, find the value of A and the coordinates of P. So now, given that this line is a tangent to the curve, we want to find the values of at the point P, we want to find the values of P and the value of A, right? So that's what we want to do for us to be able to solve this one. Right, how do you do it? It's very simple. What do you understand by the tangent in the curve? It's all about their gradients. Gradient of a tangent and a curve, they are equal at a given point. So at the point of intersection, or the point where the tangent meets the curve, the gradients of the two are the same. Remember that. Right, then now let's move up. Let me find the equations up there, the original equations. Right, we are given that the equation of the curve is what? Y is equals to x squared minus x plus 3. And the equation of the tangent, in this case, the line is now a tangent, is y is equal to 3x plus a. Y is equal to 3x plus a, and y is equal to x squared minus x plus 3. So the line is y is equal to 3x plus a. The curve y is equal to x squared minus x plus 3. Let me check again. Yes, so it's x squared minus x plus 3. That's the equation of the curve. Now, given that the line is a tangent, it means even if like this, where the point where they meet the point P, gradient at this point P is the same on both the tangent and the curve. So now, let's find the gradients of the two. The tangent, this one is easy because y is equal to 3x plus a. What you just do here, you just express in the form of y is equal to mx plus c. It's already in that form where m is the gradient. So m is the gradient, which is 3. So our gradient here, gradient is 3. So now let's find the gradient of the curve. Gradient of the curve, you differentiate, right? So you say dy over dx is equals to 2x minus 1. So 2x minus 1. Now what I'm supposed to do is what? We equate the two gradients. This one and this one. They must be the same, they must be equal. Because it's a tangent in a curve. Right, so if you can equate, then you find the x coordinate of the point where the tangent meets the curve. So it will be 2x minus 1 is equals to 3. 2x is equals to, then 3 plus 1 here, because you have to transfer this one, it will be 4. Divide by 4. Divide by 2. So you divide by 2, you get your x is equals to 2. So the x coordinate of p is equals to 2. Now we are left to find the y coordinate. How can we find the y coordinate? We use the equation of the curve. We use this one. Because the tangent, that one you can't use it. Why? Because there's an a there. You say you have to find the value of a first. So the one that don't have a is the equation of the curve. So let's use the equation of the curve to find the value of y. Alright, when x equals to 2, what will be y? So when x is equals to 2, y is equals to, it's x squared, which is 2 squared, minus x, which is minus 2, plus 3, which is equals to 2 squared is 4. 4 minus 2 is 2. 2 plus 3, it will be 5. So these are the coordinates of p. So the coordinates of p in this case, we have x 2, y 5. Right, so we have p is equals to 2, 5. These are the coordinates of p. Now we want to find the value of a. Alright, where is a? A is here on the equation of the tangent. Y is equal to 3x plus a. What are you supposed to be doing? You just substitute with the values of p. Where there is y, you put 5. Where there is x, you put 2. Then you are done. So let's substitute. Our equation is y is equals to 3x plus a. This one is for the tangent. Then where there is y, you put 5 is equals to where there is x. Where there is x here, 3 times you put 2. Then plus a. There, so it will be 5 is equals to 6 plus a. 5 minus 6 is equals to a. Minus 1 is equals to 8. So a is equals to minus 1. Then you are done. A is equals to minus 1. That's what it is. So we are done with this question. Right now, let's move on to the next question. This one is question number 7, right? Question number 7. How to work out question number 7? How can we work out question number 7? Right, this one is actually easy. What you're supposed to be doing is you have to learn how to divide your shape, right? This one is question number 7. I'm sure you can see. You can see this one. It's saying the diagram shows a circle, center A and radius R, diameter CAD and BAD are perpendicular to each other. A larger circle is center B and passes through C and D. That's a larger circle. Show that the radius of the larger circle is r root 2. Radius of the larger circle is r root 2. Right, so let's show this one, right? Let's show this one that the radius of the larger circle is actually r root 2. How can we show that the radius is r root 2? Right, so it's actually very, very easy. Let's right, so let's continue. So this one, to show that the radius of the larger circle is r root 2, the radius in this one is BC. That's the radius, right? So the radius of the larger circle is actually BC. So how can we find BC? We know that the radius of the smaller circle, AC and AB, O are R. So you can just find the BC using Pythagoras Theorem. Using Pythagoras Theorem, say r squared plus r squared is equal to BC squared. Then you can prove r squared, small letter r squared plus r squared is equals to bc squared. R squared plus r squared is equals to 2r squared. So 2r squared is equals to bc squared. If you now want to remove the square, to get rid of the square, you put square roots both sides. So it will be, here it will be square root of 2, square root of 2 then times square root of 2 then times r. Why? Because square root of r squared is just r, is equals to bc. Then this one the same as r root 2 is equals to bc. So bc is equals to r root 2. So that's how you show. Then next part, find the area of the shaded region in terms of r. Right, let's move up. Where is the area of the shaded region? Where is the area of the shaded region? It's up here. Right, so here you just have to learn how to divide your shape, right? Learn how to divide your shape. So to find the area of the shaded region, first you have to find the area of this portion that I have shaded, this one. Then after that, you subtract this area of this portion from the area of the smaller circle. That's what you're supposed to do, right? So subtract that area from the area of the smaller circle. That's what you do. If you can try to look, the area of that region is made up of, right, let me divide so that you can see. We have area of this sector, area of this sector. Let me put a letter here so that you can see. Let me put a letter x on this point. So this point I have put a letter x so that I can say area of sector BCX. So area of BCX, that's the sector. Then we also have this area. Let me use a different ink. We also have this area of this sector, which is area of sector is ABC. We have to add that one, so plus area of ABC. This one is sector, and this one is sector also. Then you also have this triangle that is appearing. It's appearing twice. This triangle at the middle, triangle ABC. This one. So you have to subtract the area of this triangle because in the first sector is there. It's included the area of that triangle. Then on the second sector is also included. So what are supposed to be doing? We subtract the area of triangle. Area of triangle ABC. So by so doing this, you can be able to find the area of this whole part, which is BCX. Then after that, we multiply by 2. Since the area of BCX the same as the area of BXD or BDX, so that you can be able to subtract the total area from the area of the smaller circle. So let's get started. That's what you're supposed to be doing, right? Remember also the radius. The radius of the, which is of sector BCX is r root 2, right? Radius of sector BCX is r root 2. Remember also that, take note of that, right? This one is r root 2, like this. Right, let's move on. So you say area of sector BCX with the radius r root 2. Area of sector BCX. So area of sector BCX is equals to, let me calculate there, it's half. Area of sector, remember, it's half r squared theta. That's the area of the sector. So it's half r squared, it's r root 2. That's the radius times r root 2. R root 2 times r root 2, then times theta. What is theta in this case? Based on this one, So here, please take note, if this angle is 90 degrees, then this angle is actually 45 degrees, and this one goes, it's an isosceles triangle. So this one is pi over 4. The same here is pi over 4. So our angle is pi over 4 in this case, right? So let's use pi over 4. So it's times pi over 4, which is equals, if you can simplify it, root 2 times root 2 is 2. So that 2 will cancel off this 2 down here. So there will be no this 2 and the root 2 1. So you'll be left with pi r squared over 4. Pi r squared over 4. So that's the area of the sector BCX, right? Now let's find the area of, let me move up. One, the area of sector ABC. Area of sector ABC with a radius of r and angle, which is 90 degrees, or which is pi over 2. So area of sector ABC, let's calculate. Area of sector ABC. Area of sector ABC is equals to, so it is equals to half r squared theta, which is half times r, that's the radius, times theta is pi over 2. That's theta, right? So if you can simplify this one, what do we get? You get pi r squared over 4. So you get pi r squared over 4. That's what you get. Now want area of triangle ABC. Area of triangle ABC. So what's the area of triangle ABC? That's the one that we want now, right? So let's calculate the area of triangle ABC. What is the area of triangle ABC? To calculate the area of triangle ABC, what you do is, you know that the two sides we have r and r, and we have the angle, which is 90 degrees, or which is pi over 2. Area of a triangle, we can say half base times height, half r times r, right? So it's half r times r. You can use half AB sine theta, but half r times r, half base times height. It can make sense. The same, which is equals to half times r, half base times height, which is equals to half r squared. Now the total area of that part unshaded, of that part, then it will be area of is pi r squared over 4, pi r squared over 4 plus pi r squared over 4 minus area of this triangle, half r squared. If you can simplify this one, you get, what do you get? If you can simplify this one, you get pi over 4 r squared plus pi over 4 r squared is equal to what? 2 over 4 pi r squared, which can be simplified to pi r squared over 2. Pi r squared over 2 minus half r squared, right? Then, in this case, this area that we have just found is the area for this part. For this part, let me show you, is the area for this whole part. Let me shade the area. Let me shade the whole area. It's for this part. Right. But want this other part that is down here. Want this other part that is down here also. This one. And the areas, they are the same. So what I'm supposed to be doing? You just multiply by 2. Because this is the whole area shaded. That one subtract from the area of the smaller circle first to get the required area. So that's what I'm supposed to do. So now you have to multiply the answer by 2. And the area of the smaller circle, remember, is just pi r squared. Radius is r, so it's pi r squared. So it's the one that you use. We subtract the area of that part that I have shaded in blue and red. Alright, so let's now multiply by 2. Let's multiply by 2 now. So if you can multiply by 2, it will be 2 times pi r squared over 2 minus half r squared. If you can simplify here, it will be by 2, remove brackets, it will be pi r squared minus r squared. Then now, area of the shaded part. We say area of the smaller circle, which means shaded area. It's area of the smaller circle. Area of smaller circle is what? It's pi r squared. So it will be pi r squared minus area of this one, this area. So you subtract this there, which is pi r squared minus r squared, like this. It is equals to, if we simplify, it will be pi r squared is pi r squared minus, remove the bracket, minus pi r squared, then plus r squared. Pi r squared will simplify to 0. So the answer that will be left is just r squared. R squared, that will be the area of the shaded part, right? So that's the area of the shaded part. Then you are done. Let's move on to the next part. Let's move on to the next part, next section. The first term of a progression, the first term of a progression is 4x and the second term is x squared. First term is 4x and second term is x squared. For the case where the progression is arithmetic with a common difference of 12, find the possible values of x and the corresponding value of the third term. Right. So given that this progression is an arithmetic progression, we want to find the values of x and the corresponding values of the third term, right? So let's do like that. Let's find the corresponding values of the third term and the values of x. Right, first what you do is arithmetic progression. First term a is equals to 4x, right? In this case, so we are given a is equals to 4x. Then we are given the common difference as 12. So our common difference is equals to what? Is equals to 12. Then also what else are we given? We are given the second term. Second term is a plus d. That's the second term of an AP is x squared. That's the second term, right? So what we're supposed to do here is, if you can say, using our second term, we said a plus d, which is 4x plus d, which is 12, is equals to x squared. Just substitute. So use this now, this equation now, a quadratic equation, for us to be able to find the values of x, right? So expressed as a quadratic equation, it will be much more easier that way, right? Then let me just take it down here. So it's 4x plus 12 is equal to x squared. Then if you can express it, the quadratic equation to be x squared minus x squared minus 4x minus 12 is equals to 0. So it will be like this, is equals to 0. Right, now let's simplify further, much more deeper. We want to find the values of x, right? This is the quadratic equation. So you have to know how to solve a quadratic equation. Right, let's find two values. When you multiply them, they must give you minus 12x squared. And when you add or subtract them, they must give you minus 4x. Which are the values now? The values are, by try and error, minus 6x and plus 2x. So you replace the new value those values minus 6x plus x plus 2x, then minus 12 is equal to 0. Then you factor out x here, you get x left x minus 6. Then on this one also, you factor out 2, you be left with x minus 6 in the brackets is equal to 0. So it will be x minus 6 in the bracket, x plus 2, x plus 2 is equals to 0. Right, it's either x minus 6 is equal to 0 or x plus 2 is equals to 0. If you can simplify it, x is equals to, then 0 plus 6, it will be 6, or x is equals to 0 minus 2 is minus 2. So these are the values of x. Now the corresponding values of the third term. What is the corresponding values of the third term? That one, what you do is, you now have to see the third term of a arithmetic progression is what? So T3 is equals to a plus 2d. A plus 2d. Since we are given our a is 4x, our a is 4x, so term 3 is equals to 4x plus 2 times our d, common difference we are given is 12, which is equals to 4x plus 24. Right now, we have to substitute these values of x. So substitute the values of x for you to find the corresponding values of the third term. So the first one, you can put x is equal to 6. Then x is equal to 2. When x is equal to 6, what will be the third term? Third term, T3 is equal to 4 times 6 plus 24, which is equals to 4 times 6 is 24 plus 24, which is equals to final answer is 48. So this one is the third term when x is equals to 6. Then when x is equals to minus 2, what will be the values of the third term? When x is equals to minus 2. So you say the term 3 is equals to 4 bracket minus 2 then plus 24. So it is equals to 4 times minus 2 is minus 8 plus 24. Minus 8 plus 24, what do we get? It's 16. So these are the corresponding values of the third term. So it's 48 and 16. We are done. Then this part, for the case where the progression is geometric, with a sum to infinity of 8, find the third term. Right, so we are given that the first term a is equals to 4x. Then the next one, the second term, which is AR when it comes to geometric progressions, is equals to x squared. Like this. Then also are given the sum to infinity of a GP. Sum to infinity of a GP is sum to infinity is equals to a over 1 minus r. That's the sum to infinity of a geometric progression. So now, what are supposed to be doing? This one we are given is 8. So a over 1 minus r is equals to 8. We are given sum to infinity s equals to 8. So now, our equation, especially this one, let's just use this one, is supposed to be in x or in r or in a, whichever is possible. Right, so in this case, let's put our equation, because we have already we have 4x as a. So you can substitute there, you can say 1 minus, then r, we don't have r, so we have to find r. We can use this second equation here to find the value of r. So you express r in terms of a. So r is equals to x squared over a. We're given that a is equals to 4x. So it will be x squared over 4x. Then from this you can simplify that. You can deduce that r is equals x over 4. So this is the value of r, right? So it's the one that you have now to substitute here. So let's put r is equals x over 4. So x over 4 is equals to 8. Right. Now I want to get rid of this denominator, which is 1 minus x over 4. How can we get rid of the denominator? We multiply both sides by the denominator. So it will be 4x is equals to 8, then multiply by 1 minus x over 4. Right, like this one. Then remove the brackets, you will be left with 4x is equals to 8 minus 2x. So let's simplify this one. It will be 4x plus 2x is equals to 8. That's collecting like terms. So 6x is equals to 8. Then divide by 6 both sides. What will you get? What will be the value of x? X will be equal to 8 over 6. By 2, it will be 4 over 3. So it's 4 over 3 like this, right? Now what we want now is the third term. What is the third term of a geometric progression? Third term, T3, is equals to AR squared. So it's AR squared. With our A is what? We have to find our A, we have to find our R. So since, let me just write it. So it will be 4x, that's our A, times R. R in this case, it's x over 4. Right? So our R is x over 4. Where is our x over 4? It's here. Up here. This one, our R is x over 4. Then our A is 4x. So now, let's substitute the value of x that we just obtained. So it's equals to 4. So where there is x, you put 4 over 3. Then times where there is x, put 4 over 3. Then this one will divide 4. So 4 over 3, this one will divide 4 like this, right? Then this one, it will be 16 over 3 times, then this one, let's say it's separately, 4 over 3 times 1 over 4. 4 over 3 times 1 over 4. So on this one, the 4 and the 4 will cancel each other. So we'll be left with 1 over 3. We'll just be left with 1 over 3, right? So that's what will be left with here. Let me finish up on this side. Right, so it will be, so from this part I am moving up there. So it will be 16. So it will be 16 over 3 times 1 over 3. If you simplify this one, what do we get? You get 16 over 9. So that's the answer that you get for right. So that's the answer that you get on this one, right? So we are done. So that's the corresponding value of the third term. Then we are done. Or you're just supposed to find here. You can even find R here first. Then you can just substitute. So R here will be what? You can find R here. You can find your R. So R here will be what? So R is equals to, since you found your x to be 4 over, your x is 4 over 3. So you can say 4 over 3 divided by 4, which is equals to 4 over 3 times 1 over 4, which is equals to, this one will cancel this one, and it will be 1 over 3. So that will be your r, right? So let's move down. Right, so on the third term, this r was supposed to be squared, this one, because it's ar squared. So you have to square this one. So it means this one will mess up everything. So if you can square this one, your r. So it means this 1/3 was supposed to be squared. So there's supposed to be a square here, a square here. So it means this 1/3 was supposed to be squared. Then it will not be this one. It will be, so this one will be, let me write the correct thing here. It will be 16 over 3 times 1 over 9, which is equals to 16 over 27. So this will be the final answer. Sorry for that error. It was supposed to square r. It's r squared actually. Right. So we are done. Don't forget to subscribe, right? So next section will also move to the next part of this paper. My name is Sir Mangeya. As I said, my numbers, I've already showed you my numbers. Plus 263 774 774 024 150. So it's plus 263 774 024 150. Right, so with these things that I've just taught you, please remember to subscribe and share the video, right? Share the video.